Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Balance Beam by Not Very Neat, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. And we have killer cages, where digits in cages must not repeat and must sum to the total given in the top left corner. So, for example, you could have something like 174 here, and this would be valid for the killer cage Sudoku, because 1 plus 4 plus 7 adds up to 12. What you could not have is, let's do this. 3, 6, and 3. Because even though this adds up to 12, you have a repeat in this killer cage. And you can't have repeats in killer cages. So this is just a typical killer cage Sudoku. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay. The first place my eye sees is in this upper left-hand box and this lower right-hand box. We have 3 cages of 2 digits each adding up to 7 and 8 respectively. Well, to add up to 7, it's going to be either 1, 6, 2, 5, or 3, 4, but since we have 3 cages of them, that must contain all those digits, which means the remaining digits in this box are 7, 8, and 9. Well, to add up to 22, you can either have 9 with 8 and then 5 here, or 9 with 7 and 6 here. And those are the only possibilities. So 9 is guaranteed to be one of these 2 digits, which means this can't be 9. You can't have 7 and 8 here because that would require a 7 there, and that'd be a repeat in the cage. And we have something similar in this lower right-hand box, right? It's 1, 7, 2, 6, and 3, 5 as the only possibilities, which leaves 4, 8, and 9 as the remaining possible digits in that box. Well, to add up to 20, you could have 8, 9, and 3. You could have 4, 9, and 7. What you cannot have, though, is 4 and 8, because 4 and 8 would require an 8 here. So it's 4, 9, 3, sorry, 8, 9, and 3, 4, 9, and 7, and so therefore one of these is guaranteed to be 9. So we know this has to be 9 here, and this has to be 9 here for these cages to work, which means in this cage you cannot have a 9. This 9 being here would basically be is eliminated by the 9 having to be in one of these 2 cells. And the 9 here is eliminated by the 9 having to be in one of these 2 cells. So what are 3 digits adding up to 21? It can only be 6, 7, and 8, right? We've removed 4, 8, 9, 5, 7, 9 as possibilities. The last possible combination of 3 digits adding up to 21 is 6, 7, and 8. Well, because of that, we know that one of these is 7 or 8, which means this cannot be 6 here. So we're guaranteed one of these is 6 here, which means this cannot be 6. So this must be 5 and 8, 9, adding up to 22, which makes this a 7. That makes this a 7. So this can't be 8 here anymore, so this must be 8 here. Since this is 8, this can no longer have an 8 here. So this is 4, 9 as a pair, which adds up with 7 to add up to 20. So 4 eliminates 4, 9 pair eliminates 4 here, so that's 8. So this is 6, 7, and 8. That means we have a 5, 6, 7, 8, and 9 quadruple or quintuplet in row 2, which eliminates 5, 6, 7, 8, and 9 in the rest of, and 7 eliminates 7 here, so that's 6, which makes that 7. This cannot be 5 or 6 here, which means this can't be 1 or 2. Remaining digits in row 2 have to be 1 through 4. But this can't be 1 or 2 because this adds up to 12 with this digit, so it's 3, 4, and 8, and 9. And this is 1 through 4, which must add up to 7 with 3 through 6. And this can't be 6 because of 6 in the box, so this can't be 1. So this is either 2, 5 or 3, 4, adding up to 7. Well, if this were 2, 4 here, that would eliminate all possibilities for this cage. So this cannot be 2, 4. It must be 1 and 5, adding up to 6. Which means this cannot be 5 here and 2 here. This is 3, 4 as a pair. That means the rest of the box must have contained 2 and 9, because this is 3, 4 as a pair. 3, 4 eliminates 3, 5 here. 7 cannot be here, so this can't be 1, 7. This can't be 7 or 6, which means this can't be 1 or 2 correspondingly. Remaining digits in column 8 are 1, 2, 3, and 5. And this cannot be 1 here, because 2 digits adding up to 11 cannot contain a 1. So it's either 2, 9, 3, 8, or 5, 6 there. 3 eliminates 3 as a possibility here, so this can't be 5 here. Okay. So these two digits add up to 6 without a 1 or 5. So that eliminates 1, 6, and 2, 5. So that leaves 3, 4 as the remaining possibility. So this 3, 4 pair eliminates 3, 4 in the rest of the box. We have a 3, 4, 3, 4 pair in row 2, which eliminates 3, 4 in the rest of the row. So this has to be 1 or 2. Okay. This 1, 5 pair eliminates 1 and 5 in the rest of the row, so this can't be 5. It's 6, which adds up to 7 with 1. So this cannot be 1 or 6 here. It's 2 or 5, which eliminates 2 and 5 in the rest of the row. This can't be 2, so that makes this 9, which makes this 2. That eliminates 2 and 6 in the rest of the column for this cage. So this can't be 1, 7 here. This is 9, which must be sum of 1 and 2 to add up to 12. So this can't be 2 because of 2 in the row, or the 2, 5 pair in the row, so this is 1, that's 2. Which means this can't be 1, that's 2 there. So this cannot be 2 here. So it's 3, 8, and 6, 5 there. 2 eliminates 2, 6 as a possibility here, so this is 3, 5 as a pair, which eliminates 3, 5 in the rest of the column and box. This can't be 5, so it's 1, which makes that 5. This 5 eliminates 5 here, so this is 3 and 8, adding up to 11. This can't be 3 or 5, so it's 1, and this can't be 3, so it's 2 and 6, adding up to 8. Okay. Remaining digits of row 1 are 7, 8, and 9. Remaining digits of row 3 are 3, 4, and 6. Okay. Remaining digits of column 7 are 4 and 6, and remaining digits of column 9 are 5 and 9. Okay. To add up to 13 for 4 unique digits, you have to have a 1. If you don't have a 1, the minimum would then be 2, 3, 4, 5, which adds up to 14, which is obviously too big. So 1 can't be here. 1 is guaranteed to be here, which means this is 7 and 1 there. 1 cannot appear here on this 9 cage, and cannot appear here in this 9 cage because of that 1 and this 1. So this must be 3 digits adding up to 9 without a 1, so it's 2, 3, and 4. 2 can't be here because of 2 in the column, so this is 2 here. And this must be 3 and 4 as a pair. These 3 digits add up to 12. And you do not have 1 available. 2 could be 2, 3, 7. And 7 would have to be here if it were. So you could have 7 and 2 and 3. 2, 4, 6 doesn't work because we have a 6 in the column. And what the only other possibility is 3, 4, 5. So this would be 4, 5 here. 3, 4, 5, 3, 4, 5. Okay. What else do we have? So this is guaranteed to have 2 or 5 here, which eliminates 2 and 5 in the rest of the column. It's 2, 3, and 7, or 3, 4, and 5, so we are guaranteed there can't be a 3 in the rest of the column. So this is one of these is 2 or 5. This is 2 or 5. That eliminates 2, 5, and 3 in the rest of the column. So the remaining digits are 4, 7, 8, 9. This adds up to 11, and we cannot have both 1 and 2 there, because these are eliminated by that. So it's either 1 or 2 with it, because if you have to have 1 or 2 adding up to 11, because if you don't have 1 or 2, it's 3, 4, and 5 at minimum, which adds up to 12, which is too big. So it could be 1, no 2 or 8. It could be 3, 7 if this is 3 and that's 7. It could be 1, 4, 6. Or it could be 2, 3, 6. Or 2, 4, 5 if this is 5. And those are the possibilities. Okay. What else do we have? This. Do we have any information on this? Unfortunately not. Right? Oh, we know 1 has to be there. 1 can't be here or here or here in this lower central box, so where is it? It's in the cage. And 4 digits adding up to 24 with a 1 must be 1, 6, 8, 9. And 6 cannot be here because of 6 in the row, so 6 has to be here. That makes this 1, 8, 9 as a triplet. This can't be 1, obviously, because of 1 in the box. So this is 1, 6, 8, and 9, adding up to 24. That eliminates 8 and 9 in the rest of the row, or 1, 8, 9 in the rest of the row, so this can't be 8 or 9. This is 4 and 7. This must be 4 or 7. Where are the 8 and 9 in column 1? It has to be here and here, then. Remaining digits in row 9 are 3, 4, 5, and 7. And this cannot be 3 or 4 because of the 3, 4 pair in the column. Remaining digits in column 6, then, are 5 through 9. Okay. This can't be 6 because of 6 in the row. This can't be 8 because of 8 in the row. Where is the 6 in column 6? Can't be in the cage. Can't be any of these cells. Can't be here. So it must be one of these two, which eliminates 6 from being there. Okay. So if this is 1, 4, 6 or 2, 4, 5, it must be 1, 4, 6 and 2, 4, 5 there. So this can never have a 4 there. 6 eliminates 6 from being there also. So this can't even have a 6. So we can have 1, 3, 7. And no 2, 3, 6 anymore. So 1, 3, 7, or it's 2, 4, 5. Interesting. Remaining digits of row 7. We have 3, 4, 5, 6, 9. Well, 6 can't be here. Where is 6 in row 7? It must be here. So this is 6 here, which eliminates 6 here. That means this must be 6 there. 6 is one of those 2. 6 has to be one of those 3. But that's not too helpful. Where is 2 in row 8? Cannot be here because of 2 in the 2 in the boxes. Can't be here because this has to be a 2-5 pair, right? This contains 2 or 5, and that's 2 or 5, which means this can't be 2 or 5 there. So it has to be here. So this is 2, which makes this 5, which makes that 2. So this cannot be 2, 3, and 7. It must be 3, 4, 5. That eliminates 3, 4, 5 in the rest of the rows or columns, so this can't be 4. This is 7, which means this can't be 7. That's 5, which means this can't be 5. It's 3, which makes that 5. No 3, 5, or 7 here means this is 4, which eliminates 4 in the rest of the box. This can't be 8 or 9 because of the 8, 9 pair in the box. So that's 3, 5, which means this can't be 3 or 5 in the rest of the row. This can't be 3, so it's 4, which makes this 9, which makes that 4. There's no more 5 here, no 5 here. We have a 3, 5 pair. Actually, this 4 eliminates 4 here. So that's 3 and 4. We have an 8, 9, and a 3, 5 pair in column 3, which eliminates 8 and 9 and 3, 5 in the rest of the column. So this must be 1 or 2 there. 4 eliminates 4 here, so that's 3, which eliminates 3 here. This becomes a 4, 5 pair, whereas the 3 in column 1, it must be here. So that's 3, which makes this 5, which makes this 3. And it cannot be 2, 4, 5 anymore, so this is 1, 3, and 7, which makes this a 2. 7 eliminates 7 in the rest of the box and column. So therefore, this is 8, 9 as a pair, which eliminates 8 and 9 in the rest of the row. So this is 7 there, which eliminates 7 here. We have a 1, 8, 9 triplet in this lower central box, which leaves 3 and 7 remaining. This can't be 7 because of 7 in the column. So that's 3, that's 7. 3 eliminates 3 here, so it's 4 and 3. 3 adds up to 12 with 9, so this is 9 and 8. Which means this cannot be 9 and this cannot be 8. 3 eliminates 3 here, so it's 4 and 3. Don't have enough information on 1s. We have 8 2s. We know where the last 2 has to be. It has to be here. Where is 4 in row 4? Can't be here because of 4 in the column. This has a 4, 5 pair in the column. This has a 4 in the column, and this has a 4 in the column, and these are filled out. So 4 has to be here. Remaining digits of column 4 are 1 and 9. Remaining digits of column 5 are 1, 5, and 8. And this can't be 1 or 8 because of 1 or 8 in the row. So that's 5, which means this can't be 5 here. 5 eliminates 5 here, so this is 4 and 5, which eliminates 4 here, so it's 6 and 4, which eliminates 6 here, so that's 9, which makes this 1, which makes that 8, and makes that 6. 5 eliminates 5 here, so it's 9 and 5. And the remaining digits, 1 eliminates 1 here, so it's 9, which makes this 8, which makes that 1. That makes this 8 also. 8 eliminates 8 here, so it's 9 and 8. 8 eliminates 8 here, so it's 9 and 8. That leaves this as a 9, this, not that. This as a 7, and this as a 6. And that's how you solve it. It's a fairly straightforward killer cage Sudoku. The only sort of tricky spot was figuring out that these eliminated the possibilities here, right, of having a 9. And that was really it. Everything else sort of flows from just normal killer cage Sudoku and what options you have available. Yep. Fairly straightforward. But I don't know. Maybe I've done a ton of killer cage Sudoku, so maybe it's easy for me, or very easy for me, to spot these. Either way, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.